In the diagram, you see an object of mass 20 kg resting on an inclined plane. It is supported by a horizontal force F. Now, what is the magnitude of F if part A, the inclined plane is smooth, and part B, the inclined plane is rough with a frictional force of 20 newtons? Let's look at part A first. So in part A, let's focus on the diagram. So you'll see this diagram here. I made it bigger so that's easier for us to draw the forces on the object. So let's look at the object itself. It is given that there is a mass, which means that the weight is now 200 newtons. And we have the x and y axis framed in this orientation, so this will aid in drawing our x and y components easily. Now, let's look at the weight of the object. We'll know that there will be a Wx acting in the x direction. Of course, in this case, this is in the opposite x-axis, and we also have a y component acting in the direction you see. Now, we will attempt to find this angle. So this angle, by looking at this right angle triangle, we'll know that this angle will then be 60 degrees because this is a right angle triangle here. With that, let us focus on the particular forces that we want. So in this case, we are interested in looking at this angle here between the weight component and the Wx component, and therefore this will then be 60 degrees as well, since Wx is parallel to the slope. With that, let's look at only the forces that we're interested in. Alright, so therefore the weight is 200 newtons and this is Wx. Now, I'm interested in calculating Wx, so therefore how do we do this? First, let's orientate the x and y axis on the free body diagram of the weight. So you'll notice that in this case, I will have a right angle triangle which I can calculate the Wx component. So you should have learned previously that this is a right angle and we'll use the trigonometric functions, either the cosine or sine. So just as a recap, this will then be the adjacent, since this is the angle and this is the hypotenuse, as indicated from the diagram here. In this case, we'll use cosine because there's the adjacent and the hypotenuse. So therefore, cosine 60 will then be equals to the adjacent, which is Wx, divided by the hypotenuse, which is 200. So doing a little bit of math, we will then get Wx to be 200 cosine 60, and this works out to be 100 newtons. Now let's look at the horizontal force F, which is supporting the object, causing it to not slide down the inclined plane. Do note that this is a right angle since this is horizontal and the weight is vertical, and therefore this angle itself will then be 30 degrees since this is 60 degrees. With that, we'll now focus on F. So by removing the rest of the forces, I'll now look at F and resolve it into the x component. So therefore, I will identify a right angle triangle again, and I intend to find Fx. So with that, I use the trigonometric functions for a right angle triangle again, and therefore I'll be able to use cosine function because Fx is the adjacent side and F is the hypotenuse. I'm able to get Fx to be equals to F cosine 30. Remember, we have a Wx component in the opposite direction compared to Fx. So therefore, if the object is resting, as indicated in the question, we will then have Fx to be equals to Wx. So let's substitute the expression and the values. So fx is f cosine 30 from here, and wx you found earlier to be 100. Therefore, f is then found to be 115 newtons, correct to 3SF. Now let's look at part B. So in part B, the only difference is that the surface is rough and has a frictional force of 20 newtons. Now what's the difference is that there exists a frictional force acting upwards since the object has a tendency to slide down the inclined plane. So therefore, we will still have our Wx and Wy as found out previously. We have a frictional force, and let's work out the Wx, which does not change based on part A. It is still 200 newtons. Now, when we consider then the frictional force over here, this will then be affected by the frictional force, Wx, and F. So when we resolve F to obtain Fx itself, we will have Wx acting in the opposite direction. We also have the frictional force of 20. So we will now write the equation. Since the object is resting, again, therefore, Fx plus 20 acting in the upwards direction along the incline must be equal to Wx, which is acting downwards along the incline, since the object is resting. Fx, which is found earlier, f cosine 30 plus 20 will then be equals to Wx. Wx is found to be 100 still, and therefore, by simple mathematics, we will then get f to be equals to 80 over cosine 30. And your answer will then be 92.4 newtons, correct to 3SF.